What we have here is that they give us information about the derivative of f and the second derivative of f, and it basically says that the derivative of f is positive for all x and the second derivative is negative for all x. Now, which of the following could be a table of values for f? So the first piece of information that the first derivative, this part here, this part right here, this first part just basically says that f is increasing always. So the first thing you need is that the f values are always increasing. F is always increasing. Now that's what this first piece means. Now this second piece, a little bit more difficult to interpret. So this second piece of information says the rate at which f is increasing is decreasing. So that means that it's increasing, but the amount of increase should get less and less over time. Okay, because the second derivative is just the derivative of the derivative, right? And if the derivative if we just say that instead of saying f prime we call that f of x, and then f double prime would just be f prime, right? And it's saying that the derivative is decreasing, and that's true. The derivative of this function is going to be decreasing. These values for f prime of x are going to be decreasing, but they're always going to be positive, which is going to make f always increasing, right? We have to follow that chain. So this is saying that f prime of x is decreasing. Or you could say the rate at which f is increasing is decreasing, right? Okay, so let's go through these values. Let's go through these tables. So it needs to satisfy both conditions. So let's look and see if we could find the one that is guaranteed to satisfy both conditions. So this first one here, it has the values of f going down, so it's not a. These values here are staying constant, so it's not increasing. It has to be increasing, so it's not B either. Now, C, D, and E, your choices for C, D, and E. If you look at C, the values for f are indeed increasing as x gets larger. So it's satisfying this first one. And so is this one, and so is E. All these values for f are increasing. So it could be just from this first piece of information, C, D, or E. We have to use this piece of information to determine which one it is. And if you look at C, right, so as I go up 1 by x, what was the rate of increase for f of x? What's the slope of the secant line between these 2 points, negative 1 comma 4 and 0 comma 5? The slope would be 1, right? That's the rate of increase between these 2 points. And then you could take the rate of increase among these 2 points, and it's 1 again. So it doesn't look like, right, that the rate of increase is decreasing. It looks like the rate of increase is staying the same for this one. But we can come back to it, and if we don't have any other option, then maybe this will be our guess. But we don't want to guess. So now let's look at D. So the rate of increase between these 2 points is 1. But then the rate of increase between these 2 points is 2, right? So I went 1 up for x, but I went 1 up along y. So the rate of increase of f of x was 1 here. And then the rate of increase along this new from 0 to 1 was 2. So the rate of increase was increasing here. And in this case, I'm just going to eliminate this, because I want it where the rate of increase, the rate, let's do this right. The rate, let's write what this means. The rate of increase of f is decreasing. And that's a mouthful, yeah, but we can sort of interpret it mathematically. The language is more difficult than the math. So again, if you look here, the rate of increase between these 2 points, negative 1 comma 4 and 0 comma 5, is just 1. And then the rate of increase between 0, 5 and 1, 7 is 2. So the rate of increase of f is increasing as I go down. Now let's look at e. So if I look at e, the rate of increase between these two is 2, and then the rate of increase between this is 1. And e is your correct choice, because you can see that the rate of increase between -1 to 4, -1, 4 to 0, comma 6 was 2. It increased by 2, right? F. But then as it went again, it only increased by 1. So its rate of increase went down, even though f is still increasing. And you could even, like, if you want, you could, to illustrate the idea of how f could still be increasing, right? So let's say I said 2, right? I could say 7.5, right? And f is still increasing. The derivative will still be positive if I put this new value here, but the rate of increase will still be decreasing, because I went from first between 1x value, right? Between -1 and 0, that's 1. That's a length of 1 along x. It decreased 2 along y. Then I go 1 along x again, and now it only decreased. It only went up by 1. Sorry. So first it went up by 2 when I went 1 along x. Then I go 1 again along x, but it only goes up by 1. And then if I go 1 up again along x, it only goes up by half. And I could keep going with this, right? I could say that, okay? And the rate at which the rate of increase of f is decreasing in this whole thing if I keep going here. And this would be like 2.7 in this one. And the rate of increase is staying constant in this one. The rate of increase was increasing in this one. Okay, go through these, make sure you understand that, again, you want to think of second derivative as the rate of change of f, right? And it's determining, it's saying something about the rate of change of f.